rows are the best. Next, we talk about noise. So here to illustrate the issue, I purposely created a new very smallish data frame, kind of like a record of people like John, Mark, Gwen. I want to point out to you that the John here, before and after, there are blanks purposely. The Mark here, there's a sort of a starting space. The Gwen here has trailing spaces. Okay, and then we have some measurements or records of numbers. I don't know what they are. It could be you know, efficiency in investment returns or whatnot. You know, so just some numbers. And the idea is some are supposed to be floating points, quite obvious. Some are supposed to be integer like, you know, to 1, 2 decimal places. And some are basically to 1 decimal place. So having a 0.0082 is not really making much sense, but somehow it was captured like that. So what should we do? Okay, so suppose now we read in this data frame. We got this. So on the right, we see this is what is supposed to be recorded. It's pretty accurate, pretty precise, with all the decimal places in place. But there are some unintended small values that are in all. I mean, we don't need to ask what is this column D. You know, I just call it D because I don't have much creativity here. I just call it D, right? But from looking at the first two records, one gets the sense that something is not right with the 00082 there, yeah, because it's probably some sort of a plus minus divide rounding issue. Maybe you have a square root and then it leaves it there. Maybe you call a library, that library is a bit sloppy and then returns with these remaining noise. It's not uncommon, and so on. So when you just capture and record like this, first of all, we don't feel right. Right. Secondly, is that while this may not seem serious, it can cause serious repercussions later on. Think of noise. All right, think of data noise. These are very categorically different in nature from the noun and the nouns, right? So these data, they are data. They are visible. They are valid. They are able to participate in statistical analysis. But the noise here is a bit like a calm lake, and then you throw a stone to disturb the surface a little bit. What happens to the ripples? So there's a bit of noise, but what happens to the ripples? It gets larger and larger and larger, right? Yeah. So when you can keep that image in mind about what is noise, why do we care? This is just a few decimal places, right? If you can keep that stone disturbance of a calm lake surface in mind, and the ripples will be the potential problems that you're going to face if you let it grow, if you give it time to grow, if you give time for the noise to grow, it will propagate, it will infiltrate into all the formulas and processing, and then gets recorded back into database and then magnify further and so on. So pretty problematic. Since we detect it now, we want to get rid of it. So the question now is how to detect it. Okay. Now, I show you here smallish data frame that we can eyeball it. So please don't trust your eyes. We want a way that is programmatic. Keep that in mind, because we're going to be capable of dealing with 5,000 columns and 6 million rows. You need that magnanimity to understand why we want to do all these things. So all magnitude that are less than 0.01 are set to 0. Okay, can we do that? How to do that? Think about apply map. Remember apply map? In data frame, apply means, just apply itself means column processing or row processing, right? So it's very vector based. Apply map will apply the function to every single element. Yeah, okay. So we apply map and we send in a function, lambda, right? Lambda is the easiest. Just create, apply, and destroy, right? Forget. So lambda x, and x here has to be each cell element. But as you can now imagine, this is not a data matrix. it is not a numerical matrix, it's got strings. So we need to be careful and make sure that if the type is a string, then we don't do anything. Okay, so this is where the if here. So this is the expression form of if. This whole line here, except the last closing bracket. This is the expression form of if. So it's not a control form of if where if starts off the statement. This is return this value inside the bracket if the type of x, check x first. If the type of x is a string, then uh, then we go to the else. But if it's not string, then return whatever is inside the bracket here. But if it is a string, then we return x itself. So if it encounters John space John space, it will return that itself. So no processing to strings, the entire column here. But if it isn't, and we know that it is just string or else integer or float, then we can run this, which happens to be another expression form of if. So then we do the same logic again. Check that the absolute value of x is less than 0.01. So all these will fail, but this negative 0.00521, that is less than 0.01. 0.00082 will be less than 0.01, right? So if it is less than 0.01, regardless of the sign, then give us 0. So we are clamping down any noise floating above and below the sea level, the lake level a little bit. So the ripple, right, it goes up and down a little bit, right? If it is anything lesser than 0.01 in height, in magnitude, consider it calm. So we clamp it down to 0. However, if it goes further, then maybe it's not due to the stone, but somebody else is sending us a signal, waving, a signal. So that is allowed to pass. So we'll return x itself if it is a bigger magnitude. So all these will be returned as they are. All right. But then only these two cells will be reset to 0, as you can see here. Okay. So as simplistic as it seems, because most of the time we're just taking x and returning x, right? It is very critical here, very, very critical. It serves as a pair of like a lawnmower. Any grass that is longer than this, cut. But this is the other way around. Okay, there are other ways, other things that we need to take care of, like all numerical values are rounded off to integers. Can we do that? How do we do it? How do we do that? All numerical values are rounded off to integer. And we are applying to the original DF8. DF8 here is applied to the original version, just so that we can all see clearly how each problem is being eradicated. But of course, in practice, we might cascade, right? So once we have reduced the magnitude to reset to 0, then we check for rounding integers, and then we, so it will cascade chain on. But here, yeah, use apply map because it's like a automaton, right? It's like run this checking machine on each cell. So apply map of this lambda, where x takes up each cell element. Again, as long as it's a string, return the cell. But if it's not a string, then it must be a float or int. Then we round x. Round x means round to 0 decimal place. Now, careful here. I just want to point out something that is quite obvious to me, but I'm not sure you can see it. When we round x, we are rounding the floating point value to integer value, but this is integer value stored in floating point data type form. So notice that when we print out, we'll get 0, 0.0, 3.0, negative 0.0. This is a bit of a noise here, but that's okay because it's just print out. Internally it's 0.0, 5.0. So it is an integer value 5 stored as a floating point form. All right. Now, our next question, strings. Strings, I'm sure if you have used Excel before, you would have encountered situations where you're scanning for John. And John, despite that you see it on screen, Excel says nowhere to be found, right? Uh, that's because there are spaces there, right? So, and if you need to really look for it, you should be typing in space John space. But who will know, right? Is it one space in front or two spaces behind? Nobody knows, and that is a problem. It's really a nuisance and it's noise. Okay, this is invisible noise, but it is clearly visible to Python and computer. So what do? Yes, we can apply map, check that if it is equal to string, the type of x is string, then we process. Otherwise